Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing process, and this particular presentation is based on the selection of the manufacturing processes. So, the topic is selection of manufacturing processes. We have seen that there are a wide variety of the processes like casting, forming, machining, welding, and then you can say the property enhancing processes like heat treatment for bulk material and the coatings etc. for surface property enhancement, and then super finishing processes. Super finishing processes. Since the each process works on the different approach for achieving the desired size and shape, therefore, the mechanical, physical and chemical properties of the material to be processed significantly affect the success of the processing by a particular process, or the productivity which will be associated with the particular process for achieving the desired size and shape. So, what are the factors that we need to consider when a selection is to be made? And of course, what we need first, there are two aspects related with the selection. One is the product features. Features which are related with the size, shape, properties, finish, tolerance, soundness or the acceptance level. So, the product related features are very wide, but as these will be determining how successfully, how effectively product can serve the purpose for which it has been made. But there is another category also which is related with the cost or the economics related with the manufacturing. So, under that only we need to see how it is to be made, so that a product can be made cost effectively so that it does not affect to the environment, it is economical, and it also serves the serves the purpose for which it has been made, its life is good, and so that the purpose of the manufacturing as a whole can be achieved. So, if we go by the different factors which are associated with the selection of the manufacturing process, those which are product based and those which are operational cost or the economics based. So, if we see the shape of the final product, raw material to be processed, the design requirement like features, hole slots, notches etc. to be achieved, the dimensional and the surface properties in form of the size, thickness and the shape complexities which are to be achieved, the tolerance and the finish which is to be achieved, and the properties that are needed in the components like a very high strength to weight ratio or very good surface properties, interior properties may not be that important. So, these are the properties that we need to consider, that we need to achieve in the product which can be made by any of the processes or by combination of the certain processes, provided that is achieved at a minimum possible cost and minimum harm to the environmental conditions. And for that, what we need to see, how much design and tooling costs are involved for making a particular product using a process, because either for casting, forming, machining, welding, heat treatment and super finishing we need one or other kind of the equipment. So, if that is available, it is fine. If it is not, then we need to make it, we need to arrange it. So, there are costs related to the design and tooling, and then lead time, how much time it will take to get the product, so that after the placement of the order. So, that the lead time is the time which is required for getting the delivery of the product after the order is placed. So, if we have that kind of luxury where long time is available, or for certain big customized products long lead time may be as long as few months to the years also, then we have the minimizing the scrap, the volume of the production, availability of the system which is needed for manufacturing. So, these are the factors related, these are the factors which will be determining the cost at which a given product can be made, and these are the features which will be governing the casting processes in order to realize these features in the product. So, here we will be going one by one through these aspects related with the processes and the product features which can be achieved. So, here this is one very basic diagram. What it shows, the in x axis what we have, the volume of the production or the number of units which are to be made is starting from 1, 10, 100, 1000, 10,000 and 1 lakh. And on the y axis we have the temperature, melting point temperature of the material to be processed. We know that the polymers will have the lower melting point temperature, then metals and then ceramics. So, for the polymers it is say from the 10 to 100, and then for the metals it is from say 200 to about like say 2000 to 3000 degrees centigrade, and for ceramics about 3000 to the higher temperature of say 7000 or 8000 degrees centigrade. So, the processes which will be having the lower melting point, they can be easily processed through the certain category of the processes. Those which have the higher melting point, they can be processed through another category of the processes. Similarly, the processes which will be involving the lesser volume, they can be made by one category of the processes. Those which will be involving the larger volumes, they can be made by another category of the processes. So, here if we see, if we try to put in this diagram, in the x axis we have volume, starting with the say here it is 0, 10, 100, 1000, 10,000, 1 lakh in the x axis, and in the y axis we have the melting point temperature. So, this is up to the 100, then up to say 1000, then 10,000. So, for the metals this is the range, this is approximate range for the metals, and this range is for the polymers, and above this it is the range say for about 3000 to the higher about 7000, 8000 is for ceramics. So, if we see this diagram, the machining processes are good for the smaller volumes, like say this is the rough band for the machining processes. For joining processes, it is slightly longer. This is for the joining processes, joining, machining, and the primary forming and the deformation based processes. So, here the deformation based processes, this is the band for the deformation based processes. Normally they are justified for the higher volumes, like 1000 to the 10,000. So, deformation based processes. So, here it will be involving like rolling, forging, extrusion, etc. Joining will be involving like arc welding and the machining. So, we can see for if the final size and shape of the product is to be achieved only through the machining, then the volumes are limited. For limited volume this can be done, but for even for the harder material, and if the joining is to be done to get the desired size and shape, then the volumes are pretty large, and you can say it can be used for the metal systems, or the systems having the moderate range of the melting point temperature, like say 200 to 1000 or 1500 degrees centigrade. And then for the deformation based processes, like hot forming or hot deformation based processes can be used for even higher melting point temperature metals, but these are justified only for the high volume productions. So, here if we see 10, 100, 1000 forming 1000, okay. So, we can adjust this scale little bit on the higher side. So, here this is 10, like 100, 1000, 10,000 and 1 lakh, like this. So, volume of production. So, high volume processes are the deformation based processes. For moderate range it is joining, and for the very low volume it is machining. Primary forming processes like the casting, this is good for the narrow range of the melting point, as well as like this. So, this is the band for the primary forming or the casting based processes. So, not too high melting point and not too low or not very high the volumes for which it can be used. So, if we see this one, this is the primary, this is the joining, this is the material removal, and this is the primary forming process, and this is the deformation based processes. So, for the low melting point systems and for joining, so this is how we can say the selection is based on here. So, the properties are basically the melting point and the volume of the production. These are the two things that govern the economics as well as the properties of the material, help in deciding the processes to be used for manufacturing a product. So, if we see the casting wise, the casting processes are normally selected for the low melting point metals and for moderate volumes. Then the machining processes, these are selected for mostly all formed and cast products are subjected to the machining primarily for achieving the finish and the tolerance. Primary shaping is not much done using the machining, and if it is to be done, then very limited volumes are used for production purpose of the machining. Otherwise, mostly machining is used as a secondary processing. So, tolerance, and then forming processes. Forming processes are used for the low yield strength and the high ductility metals, and for the high volume production. When the volumes to be made are very large, then only this high volume production processes based on the forming are justified. And the welding is used when the desired size and shape cannot be achieved through the primary forming or primary shaping processes like casting and forming, and in that case we try to use welding or joining processes, so that the simpler shapes can be brought together to get the desired size and shape. But thereafter frequently the machining is carried out for achieving the desired finish and the tolerance even in case of the welded joints. So, according to the batch size, if the product is to be made, then there are three options. Like the small batch size requires the flexible manufacturing processes like machining, which can be used for producing the variety of the geometrical features, while the large batch size allows the use of the primary forming and the deformation based processes in order to offset the relatively high cost of the machining and tool. So, the primary forming processes will be used like say from the 75 number of the units to be made and onwards. The deformation based processes will be used for more than 1000, and the machining based processes maximum up to the 500, because it is not very economical to achieve that primary shape using the machining. Now, based on the workpiece material, as I have said, the material of the low melting point metals, they are preferred to be processed through the casting route, and metals of the low yield strength and high ductility metals are preferred to be processed through the formation or deformation based processes. But still in each of the category we will see that certain unique features are there which will be guiding us to which will be forcing us to select a particular kind of the process. For example, the metals and most of the alloys related to the metals, they have the high melting point temperature. So, they can be processed in the solid form using the machining or the deformation processes, because this will be making the melting of the metals difficult, and for there are certain difficult to machine materials which cannot be machined because of the high hardness, then they require they offers the poor machinability using the conventional processes, and therefore advanced manufacturing processes are used for processing of those metallic systems. So, the metals like composites, ceramics, which uncertain metal systems like titanium alloys and super alloys having these are the difficult to machine materials by the conventional processes. So, it is preferred that the advanced manufacturing processes AMPs are used for them, and there are a number of advanced manufacturing processes like ultrasonic processes, ultrasonic machining, electric discharge machining, electrochemical machining, water jet machining. So, there are further larger more number of the advanced manufacturing process, and these processes, in these processes we are able to even remove the material in controlled way, so that desired size and shape can be achieved through the advanced manufacturing process. So, difficult to machine materials are further subjected to the advanced machining processes, so that the desired dimensions and the finish can be achieved. Like the polymers, epoxy based composites, they have the low melting point and can be processed in the liquid state. Some secondary processing is like the machining is needed in order to achieve the desired finish and the quality, and sometimes advanced manufacturing process is preferred for processing the polymer matrix composites with the fibers, fillers, because of their brittle behavior. So, certain the composite materials of the polymer base can be processed using the advanced manufacturing processes, but means especially to deal with the brittle behavior of such metal. Otherwise, mostly because of their low melting point, liquid state processing of the polymers and the plastic is carried out. Now, we will see the ceramics, which are usually brittle and difficult to process in solid form using the conventional processes, and therefore, conventional machining processes are normally not applied, even the there because of high hardness and brittleness, they are difficult to be processed through the forming based processes and the joining based processes. Therefore, advanced machining processes are used for processing the ceramic materials, and therefore, sometimes a special process like powder metallurgy technique is used to get the desired size and shape, or they can be advanced manufacturing process can be used to get the desired shape and the surface quality when using the ceramics. So, as I have said, there are various processes which have the different kind of the capabilities. For example, the castings is the fastest route to get the complex shapes, but very thin sections cannot be made. The forming is the best method for making the simpler cross sections, simpler shapes at very high rate, provided the volumes to be produced are high. So, the forming will be good for those processes, and the machining is good for achieving the desired dimensional control and desired surface finish. The welding is used for fabrication of the products which otherwise cannot be made by other manufacturing processes. So, the welding or the joining is to be used only under those conditions, primarily in those conditions where the given shape cannot be achieved by other processes. So, but each of the process will have certain capabilities to produce certain dimensional features, to produce the surface properties, and to offer the certain the tolerance which can be achieved by a given process, and the kind of finish which can be achieved by a given process. So, now we will see that how the surface, what kind of surface roughness can be achieved by the different kind of processes, and what kind of tolerance which can be achieved by the given manufacturing process, because among the features or the properties desired in a product, the roughness and the dimensional control over the proper dimensional control of the product is important, which affects the functionality and the performance of the product, and that is why we will be seeing one by one the kind of roughness. First of all, we will be talking about the roughness, and thereafter we will see the tolerance which can be achieved by the different processes. So, starting with the roughness. So, if you see the casting processes, in the casting process as cast component, here what we can see, this is like the casting process have the die casting, investment casting, and sand casting. So, what we can see the range of roughness which can be achieved. So, the first here we can see 1 to 2 is the roughness Ra in micrometer for die casting. Similarly, for investment casting roughness is 1.5 to 3 in micrometer, Ra in micrometer. So, here now we will see the sand casting offers the poor surface finish as the roughness is high in range of the 12 to the 25 value. But the die casting offers quite good surface finish which is in the range of 1 to 2 micrometer. If we see the machining processes, boring offers the good finish ranging from 0.5 to 6, and similarly most of the processes we can see the turning 0.5 to 6 and the shaping 0.5 to 1.5 to the 12. So, it is we can say here 0.5 to 25 is the micrometer roughness in Ra which can be achieved by the different machining processes. So, this is this kind of machining processes are mainly used for achieving the desired shape and size. For finishing purpose we may use another category of the processes which are like abrasive processes. On the other hand, if we see the grinding processes offers very close very good surface finish ranging from 0.1 to 2 micrometer, and the honing 0.1 to 1, lapping 0.05 to 0.5, polishing 0.1 to 0.5 and super finishing 0.02 to 0.3. So, very good surface finish can be achieved through the abrasive based processes, especially the super finishing processes. On the other hand, if you see thermal cutting offers very rough surfaces like 5 to 25, Ra, flame cutting offers 12 to 25 and plasma arc cutting offers 12 to 25. So, very rough cut surfaces are produced by the thermal cutting methods. If we see the deformation based processes, cold rolling offers the good finish in range of 1 to 3 micrometer, cold extrusion offers 1 to 4 micrometer. In comparison to the cold rolling, hot rolling offers the poor rough surface finish, and roughness is in the order of 12 to 25, and reason for this is that when the material is processed at elevated temperature it gets oxidized. So, that oxidation adversely affects the surface roughness of the material. So, we can see the casting, machining, abrasive based processes and thermal cutting processes each offers the different kind of the surface finish, and the finish which will be realized in a particular case that will depend upon the metal system which is being processed and the process parameters, the tool condition, stability and the robustness of the machine. So, there are various parameters which will be affecting the actual surface finish which can be achieved during the processing by a particular process. For example, here sand casting offers the higher surface roughness as compared to the die casting. Coming to the another important feature related with the important characteristics related with the manufacturing processes which will be determining the kind of control over the dimensions which can be achieved through a particular manufacturing process. For example, for sand casting, when the cast iron is processed, control over the dimensions is to the tune of plus minus 1.5 mm. For steels it is plus minus 1.5, and for aluminum it is plus minus 0.5. I will just correct it, for cast iron plus minus 1.3. In case of the die casting, the dimensional control which can be achieved is plus minus 0.12. So, very close dimensional control can be achieved here we can see in case of the die casting, and which is much better as compared to the sand casting process. Then coming to the machining. So, machining offers the dimensional control like as per the diameter or as per the size which is being processed up to the 6 mm diameter. The dimensional control is possible in the range of like say plus 0.08 mm to the minus 0.03 and up to say 25 mm diameter. This is possible in the range of say plus 0.13 to minus 0.05. For milling it is plus minus 0.08 and for turning it is plus minus 0.05. So, very close dimensional control can be achieved through the turning and the milling processes. Then abrasive grinding, abrasive processes offer further closer control over the dimensions, but that is what we can see from the very close tolerance limits. For grinding it is plus minus 0.08, for lapping it is 0.05 and for honing it is 0.05, and the non-traditional machinings offer further somewhat higher the tolerance limits, like for chemical machining it is 0.0 plus minus 0.08. So, we can see that the different processes have the different capability to produce the different number of the products of the different metals, having the variety of the metal systems economically. So, there are certain processes which can produce the low melting point metals in a smaller volume effectively. There is another category of the process which can produce the high melting point metals in the larger volume. There is another category having the moderate melting point and the very large volumes which can be processed through the forming processes. So, for each kind of the material which is to be processed and the volume which is to be produced, they are different, and according to the material to be processed and the volumes to be produced, we need to select the suitable process. At the same time, we can also see the each process offers the different kind of the surface finish as well as the dimensional control which can be achieved. So, in light of the requirement of the product which is to be made, we need to select the suitable process. So, here now I will conclude. In this presentation we have talked about the various technical factors which need to be considered for selection of the manufacturing process, and there are two categories of the parameters which we need to consider. One is the category of the features which are needed in the product to be manufactured, and another is related with the cost or the economics. So, considering both the factors, we need to select the suitable process so that the desired product can be made cost effectively without harming the environment, and the entire manufacturing system is effective. Thank you for your attention.